Okay, can you hear me? Boleh. Okay, so yang turn on mic tuh nanti tolong off ah. Dia ada echo tuh. Okay, so we will continue with this lecture, lecture number 7. So we will discuss about the document, about the property of the document, how do we measure similarity of document, and other more. And also the whole process of processing document for measuring or preparing them to be compared. Okay, in most cases, we are trying to compare how similar the content of the document. So before we can compare, we need to know the format, how do we pre-process them and prepare them to be um, compared. Okay, so this lecture will outline several concepts like metadata, document formats, text properties, document pre-processing. Okay, so our main idea is we want to look at the all the stages that we have in document pre-processing. Okay, and at the same time also we will look into some of the algorithm used to compare documents. Okay, so when we have the document in your small project later on, you will have to process the document. So the document is considered as a single unit of information. So let's suppose you have a PDF file. So how do you open the file, and then how do you pass the file line by line, and then you tokenize each term that you have in that document. Okay. So for each document, they have their own syntax and structure. So syntax referring to what? In programming, we have syntax and semantic kan? Okay. So in your programming, in your first course in programming, you were told that in your program you have syntax and semantic. So syntax referring to the structure of your program, and semantic refer to the logic or the meaning of your program. Okay. So when we have the document, we have to know what is the format of the document, how do you differentiate between the title and also subtitle, and how do you find the author, how do you find the address of the author, how do you find the email, and how do you find the graphic, and many more. Okay, so those what we call the data about the data, metadata lah. Okay, and each document also have their punya own semantic, like the meaning, the concept that they try to put across using the document that they have. So this is specified by the author, and each document may have different presentation style. Okay, so given by its syntax referring to this structure, and also given by the semantic, which is the meaning of the document.
Doctor,
Yes.
share screen, Doctor.
Oh, you didn't see the slide bahkan?
Can see.
Okay, you didn't miss anything, just first slide saja lah. Okay. So this is the whole idea is that each document will have their own syntax and structure. So syntax referring to the structure of the document and semantic referring to the content or the meaning of the document. So each document may have their own presentation style. Like when you type your FYP or any report, you asking for the format of the report from your lecturer. So similar to your report for your FYP, you must follow exactly the format given by the faculty. Okay. So when a lecturer get your FYP proposal or FYP report, then um, we try to read your proposal, and of course we have requested you to put some info, and we have outlined the structure of your report. So you must have introduction, you must have literature review, research methodology, you must have objective, and so on. So let's suppose you wanted to have a program that will extract research objective from your document. So how would you do that? Okay, you open the PDF file, and then you are trying to find the list of objective that you have in your document. For us lecturer, easy. We just look at the keyword. The objective of this project is this one, this one, this one. But if you were to write a program and then to extract those research objective or project objective, you need to be able to identify which area or which keyword that you wanted to look for. So that's why we, we need to know the syntax, the structure of your report. And also by looking at the keyword or by looking at certain structure, you may be able to find what you are trying to look for. But this is done by the program itself. Okay, you program your code lah. Okay, so if you have any question, you can stop me. Okay, so the document syntax referring to the structure or the presentation style of your program. So you have the document. So you give syntax the structure of your document, and then based on the structure, you have your own presentation style, and also the structure, and also the semantic. The semantic referring to the meaning, okay, the concept that you're trying to put across. Okay, so you may have one or more element might be implicit or given together. So you may have presentation style only, or you have semantic and presentation style together, and so on. Okay, so this is the example. We for the document style, we may have a chapter, we may have the title, and we may have the section number. So this is the chapter, this is the title, this is the author, and this is the section number. Okay, subsection. Okay. So if you ever try this, what we call LaTeX, this is a program that like you program to write a text report. Okay. So for example, this is the sample of program that we have. So for example, here we say, okay, section is introduction, and the label is in introduction, and we have the citation here. Okay, citation here. So this citation will cite whatever today 9 or today 10 outline in another file. Okay, so what it will looks like, it will looks like this. So you see that this is the title. This is the citation that we have. Okay. So for a certain symbol like the percentage, they use the backslash. So this is one of the example that we use LaTeX in order to structure or format our document. Okay. So from here we have section, we have subsection, we have figure, we have author, and so on. So by looking at this keyword, we know already what is this text refer to. Okay. Okay. For queries in search engine, we try to find certain text depending on our intention. Okay. For example, um, let's suppose we are looking for bank, but bank will have different meaning depending on the context on how we use them. For example, bank of river and bank account. So there are two different meaning here depending on how you use them. Okay? So when we look for certain concept, we normally look at the for example, we look for bank, but we also look at what is um, after the bank and what is before the bank. So we know that how the bank is used with with the context of the other word that we have in our document. Okay. Let- okay. So when we try to look for certain information, it's good to put more than two or more than three because we want to know what how the keyword is being used, the context on how the keyword is being used in trying to find the best match of the document. Okay. Okay. Now we look into metadata. So this is what I mentioned just now, the data about the data, the information about the data that we store in our um, storage. Okay. So metadata is information on the organization of the data. How do we represent them? Okay. What is the meaning? And also how they are interrelated to each other. So this refer to various data domain and how their relationship are. Okay. So for example, in database, we have the table, the relation, the primary key, foreign key. Also, we have the attributes. So what type of attribute do we have? Integer, floating, string, and many more. Okay. But in text document, we are looking at the author, who are the author of the text, the date of the publication, who published them, the length of the document, and most importantly, the topic and the content of the document. Okay. So this is the metadata that we want to know. Okay. For the author, easy to detect, date of publication, easy to detect, source, who published them, easy to detect, the length of the document, we just count, but this is the most important part. Topic or content of the text. Okay. How do we perform topic modeling? How do we decide this document belong to certain topic? So that is the major issue that we're trying to address in information retrieval. Okay. Okay, so metadata is associated with most document and text collection. So we are looking at all this information like the title, the physical description. Okay, so last time they used this what we call catalog card. So the catalog card store all those information. So during my time, or maybe you have experienced this one before, where you look for the book, we use the catalog card. But now all has been digitized into a system. So you just look at the catalog card system. Okay. So the catalog card system will store all those necessary information. Okay. Okay. So when we talk about, okay, I go back here. Okay, if you look at this catalog card, we do not have a complete text, but we have some kind of description, but we don't have description here. This one. Um, no, they just say all the number. Okay, but what we want to know is the semantic metadata. Okay, semantic referring to meaning. Meaning of the metadata. So this semantic metadata characterize the subject matter within the document content, like I mentioned just now. How do we design a program perform that will be able to perform topic modeling, like decide what is the content of the document and which category they belong to. Okay, so semantic metadata is usually associated with a wide number of documents. Okay, so for us to look into the meaning of the document, we have to have a large number of documents. Okay, and the requirement for the semantic metadata is increasingly important because every day we have more document stored in the um, di- digital format. Okay, and this machine readable cataloging record has been implemented to replace the old manual catalog card. Okay, so this is most used format for library, and this include all the distinct attribute of bibliographic such as title, author, publication venue, and so on. Okay, so this is the sample machine readable cataloging record. So you can see that they have all the reference, the subject, the owner, call number, and so on. Okay. So, but in web, for the web document, we also have a metadata that will capture all the basic information about the web document. Okay, so due to the increased number of documents that we store on the web, so metadata in a web document becoming more important because we want to speed up the process of finding the author, the who published this, who on this page, and then the title of this page, and so on. Okay. When we look at this one, it says that the increase in the web data has led to many initiatives to add metadata information. So we need to add this one because this one will serve the purpose for other like cataloging and content rating. So when we perform content rating, we always give credit to the author. also for intellectual property, because we want to know who is the owner of the web. Okay, and also if you want to promote certain things, so we can also um, apply the metadata information in the application to e-commerce. Okay, so when we talk about the metadata in web document, so the most common technique method used is called Resource Description Framework, RDF. We will not go deeper into this, but we will just give you an idea what is the RDF. So this is the new standard for web metadata, okay? And it allows describing the web resources to facilitate automated processing. So by having the information about who is the author, what is the title of the page, and so on. So this basic information can be produced using the RDF. Okay. So the RDF does not assume any particular application or semantic domain. So we are looking at this as the main node. So for example, if we are looking at up to this stage, so this is what we call the URL. Okay, so URL start from the HTTP until end of the here. Okay, but when you have this symbol and other symbol that connected to the URL, okay, so this is what we call the uniform resource name. So this is the name. Okay, but all together this is called URI. Okay, together with the HTTP. Okay, so when we have this RDF, we will have three different definitions that will be used. The first one is URI, which is the whole list, and the URL is up to the file name. Okay, this is up to the file name, and then the URN is the whole thing except the HTTP, because the HTTP we have the HTTPS again and so on. Okay. Okay. Now we look into a basic definition of resource description framework. So this is a model for representing the name properties and the property value. Okay. So the name property, this one we can decide by ourselves, and then we can put value to this property. Okay. For example, like we have resource, and also we have property, and then we have statement. Okay, so the statement um, will specify the resource together with the name property plus the value. So we have the property, and then we have the value that we want to have for that property. So for example, you want to have the author, and this is the author, let's say RA. Okay, so but this is the basic statement. But when we write in using the RDF, they use different format. Okay, so for example, uh, if we have the three tuple, so we have the three tuple representation. So here we will have, okay, this is the subject that you have, and this is the predicate, and this is the value. Okay, so this is the property, this is the value. So when we try to put them, so we are saying that, okay, this is our resource, this is your resource. Okay, so this one could be your URL, IURLURN. Okay, and the no, yeah, this is your resource, and the prototype will be this one, the author, and the value will be this one. Okay, so we will have something like this. So we have this is your resource, this is your property, and this is your value. Okay, so that is the basic information about resource description framework, in which we can, for example, this one, the property type, we can use any property that we want. Like, for example, title. We have other things. So the predicate is the what type of property that you want to have, and then the subject is this one, and then the object is Jane Sharela. Okay, so that is the some of the basic information about metadata in web document. Okay, any question? No. So far, okay. Okay. So now we look into information theory. So information theory, we use or we learn this concept in order to know how much information a symbol carry in a text. Okay. So for instance, in most cases, like we have the ataupun is ataupun all of these carry less meaning because they occur so many times compared to the other terms. Okay, so we will look into this information theory. What is the formula looks like, and how do we generalize this formula in order to compute the importance of certain terms with respect to the other terms in the document. Okay, so what is this information theory? Okay. Um, it states that it is difficult to formally capture how much information is there in a given text. Okay, so normally a text may carry no meaning or may carry the most important meaning in the whole document. Okay, for example, like this, we have a and then there and is. So a text where one symbol appear almost all the time does not convey much information. Okay, so this would the is always appear in the document. We can say that they are um, the most number no, they occur in most of the time in the document. Okay, so we want to have a formula that can define how much information a term can carry. So we use this information theory to define a special concept, what we call it entropy, to capture the information content. How much information can this term carry? Okay, the less number they occur, the better they are used in order to differentiate the document. Okay. Okay, what is this entropy? So let's suppose we have a text T and we have this symbol T1, T2 up to Tn. So we have n symbol. Okay. So for this one, we look at the entropy. based on the probability of having that symbol in the text. Okay, so the I going to n, so n referring to the n symbol that we have. Okay, so this is log 2 1 over the probability of having that symbol, and then we average them by n number of symbol. Okay, so it is important to note that the E is a property of the model. So this one can be used to model the whole document and not only a single text. So for example, if we have this in a closed model given University Malaysia Sabah. So let's take a look at the first text here. Okay. So the probability of U is 1 over 23. So 1 over 23. So meaning that we have 3, 3, 4, and then 3, 3, 4. So we have 23, 23 non-empty symbol here in this text. Okay, so we have P, Pn. So Pn we only have one, and then I we have 1, 2, 3, 4, 4, and then so on and so on so on. So for the T we have one, one only. Okay, so when it comes to the whole entropy for university, so we apply this formula. Okay, so this one is because we only looking at this, so 1 over 10 lah. So we have 10 document, 10 symbol there. And then this is the probability of the whole U for the whole document. Okay, so we compute everyone here and so on. And then we get the final one lah. Okay, so the value is 3.774. Okay, so this is the value of entropy for the university. If you look at the value here, okay, let's suppose we have one example lah. When this is getting higher, what is the value? What is, let's suppose the probability of symbol I. Let's suppose we have this one is 2. Okay, and let's suppose the probability of this one is very high. So this is going to 0. What is log base 2? Log base 2, 0. Anyone? Log base 2 kosong lah tuh kalau match 0 lah kan. If you cannot compute, then it is 0. Okay, because if the probability of this one is high, so this is 1. Kan? What is this one? Log base 2, 1, 1. log base to 1 is 0, right? Berapa? What is the value for this log to 1? What is the value? 0, kan? So this is 0. So that means if the probability of symbol of that particular symbol is high, so your value for your entropy will be 0. So that means carry less meaning. So if your value is entropy is high, so that means you carry more meaning lah. Okay, boleh. So for example like this symbol A. Okay, so the formula for this one will be entropy because we only have one, so this is 1 over 1, and then the summation actually I 1 so log 2, and this is the probability of having A. So if A occur so many times in your text, so it, it will it will go up to 1, kan? So if this is log 2 1 over 1, then the whole thing will be 0. So your entropy will be 0. So meaning that the lower the value for this, meaning you carry less meaning. Okay? So if you have high number, that means you carry more meaning. So that's how we use the entropy for the information theory. Okay. Okay. So because of this, we have generalized this one. Um, so if the model always assign probability pi to the alphabet symbol this, the entropy can be rewritten. So we can rewritten the formula just now to become like this. So this one looks familiar in your formula that you learned before. Okay. So we are looking at the probability of that particular symbol only. Okay. So we put negative here because the whole thing will give you a negative value first. Then to neutralize this, we get this one. Okay. Okay. So where this one is the alphabet, list of alphabet, and this one is the length of the alphabet. So this is the length of the alphabet. Okay. You have the exercise later on. Okay. So any question that you want to ask? No? So far, okay. Are you feeling comfortable with the information theory, the formula here? Let me erase this. Okay. So let me repeat this one. So meaning that if your entropy is higher, so uh, the word carry more meaning. So if the value is lower, it will carry less meaning because they occur so many times. So this one will be uh, going to 1, and then when you get log to 1, you get 0. Okay, okay, let's take a look at the next one. The next one is modeling natural language. So I believe you learned this one also in text mining. Okay, so for the natural language, we can divide the symbol of the text in two disjoint subset: symbol that separate the word and symbol that belong to words. Okay, so but we also know that symbol are not uniformly distributed in the text. So, for instance, in English, the vowel are usually more. What are the are the vowel? A, E, O, U, I. Okay. Okay. How the different words are distributed inside each document? So we can use this zip law, okay, to model the distribution of the word. Okay. The zip law saying that the frequency Fi of the I most frequent word is given by this. Okay. So for example, if you have word I am Batman. Okay. Ini contoh sajalah. Okay. They say that okay, what is the frequency of the Fi of the I most frequent word in word is given by this. So for example, if in your text you have this one I exist 10 times, this one 7 times, this is 9 times. So the first one will be I, okay, and the second one will be Batman, and the third one will be M. Okay, so when we have this formula, so if I want to have, okay, let's say the second most frequent, this one is 1, um, this one is the 2, but the alpha here is always 1. Okay, so when we want to know this, so basically we have 1 is 10 and divide by 2, so the value is 5. Okay, so they said the frequency for the second most frequent is 5, but in our ni is 9, so more or less the same lah. So what they want to say is that the most frequent the I most frequent will go down in a curve. Let me erase this one to show you the graph. But basically, this slide is only describing you the formula. The graph is on the next slide. The next slide is this one. Let me show you the graph first. Okay. This is the distribution of the most frequent word that we have. But if we look at the formula again here. So just now we were here. Okay. So where F1 is the frequency of the most frequent word, like I show in the example just now. Okay, the first one. And this alpha is a text dependent parameter, normally one. And, and for a text of n words with vocabulary of V, so this is the list of distinct word that you have in your vocabulary. This one is the n word that you have in your document. So what we have here, okay, so they said that the n here is basically accumulation of all the vocabulary that we have, okay, from I to V. So V is the number of distinct words that you have in your dictionary. Okay. So, but we also have this the n when we replace this one with this one. So you have this one. So this is basically the same with this. Okay. And we can replace with the fi here. Okay. You see the changes here. Boleh? How we transform this? Let me change the color. Okay. So this is equivalent to this based on the zip law, which is here. Okay. So when we simplify this one further, so we take out the F1 here, put them outside here. Okay. Then we get this one, and that one is, so we take this one down here, so we get this one. So this is how we find the F1. So we take the n number of words that we have and divide by this. Okay. So we can estimate F1 here. So we can estimate F1 here by using this formula, or we can compute what is the most frequent word that you have in your text. But we could also estimate. Okay. So this here is the formula on how to estimate the F1. So based on the F1 here, then we can compute um, the I most frequent word given in the text. Okay. Okay. So when we look at the graph here, the frequency of the words, okay, certain word will have high frequency here, and we also have the number of word here. Most would have low frequency. Okay, so most of them here. So what we want to do here, we want to eliminate all this, because as you can see that if the frequency is high, the probability of that word is high. Kan? So when you have probability of I is high, so your information theory, how much information carried by that particular symbol will be low. So we want to eliminate this part of your text here. So this will reduce the computation time to cluster or to categorize your document. So normally we remove 40% to 50% of the um, word that you have here. So for example, all the word that has frequency more than this, you will eliminate. Okay. Okay. So that's why we remove this in your text, because this a, the, by, and they occur so many times that the probability of having this one is high, so they carry less meaning. So that's why we remove them. They are called the stop word. Okay. So therefore, half of the words appearing in the text do not need to be considered half. Look at this half. So meaning that if I go back to the previous slide, so 40 to 50% of the text that you have in your document, you do not have to consider. So you reduce the time to uh, compute them later on for similarity or for clustering and many more. In the next lecture, we will look into clustering and then classification. Okay. Okay. We also have the vocabulary and also the text size. The text size referring to the number of symbol used in the text. Okay. As you can see that as your vocabulary going up, we also have this one going flat here. Okay. So your text size will be reducing here until you have a flat line in which you cannot put more symbol because they will be meaningless. Okay, but bear in mind that we do have long text size, for example, like this one. So this is 45 letters. So this is a supposed lung disease. So this is the number of symbol that we have. We also have this 29 letters and so on. Okay, so that is what we call the text size. So the text size here, as the text size increase more, the number of vocabulary is growing, but um, you will have a steady rate here. Okay, we cannot add more here because the word becoming meaningless. Okay, okay. Now we go into some computation on how do we um, perform text similarity. Okay. Um, Normally we use this in the application of trying to find the exact answer. Or, for example, if in the exam, in most cases you will have multiple choice question. Okay, so it is easy to mark that one because you just pick A, B, C, D. But what if you have a subjective question in which you try to give marks according to the answer that given by the student, but you want to have a program that will automatically give marks depending on the text similarity of the answer. Okay, what we want also to have concept similarity. So the idea that the student presented in the answer is similar to the concept that the what we call it, the answer schema. Okay, so let's start with the basic one, text similarity. Okay, yeah, for those looking for FYP also, FYP proposal, this is a good proposal also because we want to have um, a, a program that will evaluate the answer of the student with respect to the schema question answer. So how similar is the question, and then the module should be able to give marks according to the level of similarity. Okay, so this is a very interesting FYP project as well. Okay, text similarity, this is referring to one single text. Okay, the first one is called distance function. Okay, so the distance function is referring to um, the number of position with different characters. Okay, so for example, this will have one distance function If you have 0, meaning that they are similar. If the number is higher, meaning they are far away. Okay, so this is what we call Hamming distance also. So they count the number of different character for the two texts that we have. Okay, this is easy to implement. Okay, addition function should also be symmetric. It does. In this case, the order of the argument does not matter. So if you are looking at two texts or three texts, so you can should be able to compare them one by one. Okay, okay, and they say that it should also satisfy the triangle inequality in which the distance between A and C is less than or equal to distance AB. So if you have A here and then B here and C here, so the distance between AC um, should be less with this one. So this one is plus. So between AB and BC. Okay. So this is when we have three woods. Okay. So this is the assumption that we have. Okay. We also have the Levenshtein distance in which it count the number of operation that you need to do in order to make them equal. So for example, like this one, the number of operation is 1 because you need to add u. Okay? And for this one, the number of operation that you need to do is you need to perform two. One is to replace v with g, and also you need to delete r. Okay? So this is what we call edit or Levenshtein distance. Okay, extension to this concept, different weight for each operation can be used. So for example, for this one, um, insertion, deletion, substitution, they all have equal weightage. We could all, for example, this is 1 1 1 operation. Okay, but we could also have weightage where we say, okay, this is half, and this is 2. Okay, so meaning that for this one, if you substitute, will be 2 plus 1 half because we have half here and then 2 here. So it will become 2.5. Okay. Okay, we also have this longest common subsequence. So this is referring to the longest sequence that you could have. So for example, like this, the longest common subsequent will be this one, Surrey. Okay. So these are all the methods that we can use in order to measure the similarity of text, a single text only, a single text only. So you could do this one for the whole text in the document that you have. Okay. 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 The final ingredient for this lecture is this one, text similarity. Okay. So we use this what we call resemblance measure in order to measure the similarity of two texts. Okay. So by um, in this formula, we are looking at the number of words that intersect with each other divided by the number of words that we union from both texts. Okay, so if the value is 0, meaning that they are similar. if the value is 1, meaning that, let me see, if the intersection is high, okay, if the value is 1, meaning that they are similar. If the value is 0, meaning that they are not similar. Okay, so this resemblance measure can be easily transformed in a distance function. Okay, so the distance function should be uh, minus from subtracted from 1, because if they are similar, this is 1. Okay, so if they are similar, 1 minus 1, the distance is 0. Okay, okay, let's take a look at how do we apply this resemblance measure. Okay, so we use the same document that we have for the previous exercise. The first thing that we need to do is we want to look into what are the unique symbol that we have, what are the unique text that we have in your document. So we have this. These are the unique items in each document that we have. Okay, so if you want to find the resemblance between D1 and D2, okay, D1 and D2, this one. So basically, we are looking at the intersection 1, 2. Okay, so we have 2 here, and then when we join them, so we have this one is 7 plus 2. Okay, so now we have 9. Someone open mic. Can you turn off your mic? Uh, Nitya, Nitya, can you off your mic? Nitya, okay, okay, okay. So if you want to find the resemblance for document 1 and 3, so document 1 and 3, we are looking at the common one, B and D. Okay, so they are 2. So this is 6 plus A and C. So you have 2. So we have 8. Okay, so that's how we find the resemblance between two documents. Okay, and the distance, so we just subtract from 1. Okay, very straightforward. Okay, but this one, this is looking at a perfect matching between two symbol. But we could also incorporate the what we call it, the text similarity, based on the 3 common method that I've shown you just now. So plus that one plus this one. Okay. Okay. So we come to the end of the lecture. So when we look at the document pre-processing, we have the lexical analysis of the text. We have elimination of stop word. We have stemming, in which we find the root word of the word that we have. We have selection of index term, keyword, and construction of the thesaurus. So in the lexical analysis, we process or converting stream of character into stream of words. So basically, we are looking at the word. We tokenize the word from the text. So we have to look at the space, the number, normally we remove this one lah, the hyphen, punctuation marks, and we normalize the case of the letter. Okay, like the B, we change the capital B, we change to small letter. And then stopwood are all these. Okay, so in most cases, we could reduce 40%, 40% of them. Okay, we also perform the stemming, in which we find all the root word of the wood. Okay, and keyword selection. And if you look at the whole process, this is the document that you have. And then we look at the structure, and then we tokenize them, and we remove all the symbol that carry no meaning. We also remove all the stopwoods. We identify the nouns group because these are the main idea or main concept that we want to capture. We perform the stemming in order to reduce the number of keyword that we have. Then we form the vocabulary that we have, and we have the final one. So the reason why we want to have this taxonomic keyword is that when we want to perform the TF-IDF, okay, so remember that we have all the keyword I, keyword 2, keyword 3, and also document 1, document 2, and so on. So what we want to do is we want to have a good one here, a good list of vocabulary here. Keyword 1, 2, 3, and so on. Okay, so the more information carried by all this keyword, the better your next process will be, which is clustering, similarity, classification, and many more. Okay, so I guess that is the end of the lecture. And do you have any question? Sure, no question.